taking care of parameters you don't have to with ParamTools. My name is Hank, and I work on Compute Studio, which is a website for publishing and running computational models, data visualizations. Also on the Leadership Council of the Policy Simulation Library, which is a home for open source public policy models. Hello, PyData. ParamTools is a parameter processing library. Thanks for having me. Now let's learn more about ParamTools. ParamTools helps you document your model's inputs and validate your users' inputs. It's built on top of Marshmallow, which gives it a nice foundation, and it makes it easy to extend ParamTools and add custom data types. But more broadly, ParamTools is a way to share your models with others. Who's using ParamTools? Matchups. This is a little app that I made that's on Compute Studio, and you can analyze pitching and batting matchups for Major League Baseball players. Pi21 is a project one of my friends made, and you can analyze different strategies for blackjack, and ParamTools is used under the hood to parameterize the rules of blackjack, so you can see how your strategies work out under different game scenarios. Tax Cruncher. This is a model in the policy simulation library, and this is just showing how Tax Cruncher reads in ParamTools inputs from JSON files. So why ParamTools? The policy simulation library has a bunch of tax models in it, and they directly depend on each other, and they're all mostly focused on the US tax code. So that means their inputs are very complicated because that's just how the US tax code is. And one of the models, Tax Calculator, had a really nice parameter processing backend. And other models in PSL really liked it, and they liked it so much that they took how Tax Calculator approached this problem, and they used that for their projects too. And by that, I mean they copied and pasted this parameters class into their repositories, and then they modified it so that it would work for their projects. This was a really nice solution, and then general pattern was working really well for a lot of different projects. But in the end, the maintainers of these projects wanted to focus on the things that they were modeling, and they didn't want to have to maintain an 800 to 1,000 line long module that's not doing anything that's directly related to their model. So I saw an opportunity to make a new package that could do this heavy lifting for the models, and that's when ParamTools was created. ParamTools provides a standard format for model inputs. It's based on the format that Tax Calculator uses. And I tried to make this format general enough to work for all kinds of models, not just ones in PSL, but beyond. It validates inputs. It makes parameter values available as NumPy arrays. This makes it easy to integrate with the rest of the PyData ecosystem. And at the same time, as I was building ParamTools, I was also building Compute Studio, and I wanted to build something that would make it easy to build web interfaces for Python models. And ParamTools fit that mold because it was able to communicate over different processes just using normal JSON. So now we're going to hop over to a demo, and we're just going to build a really simple tax calculator. And this is going to help demonstrate some ParamTools concepts, and I think in an interesting way, especially in light of all the tax talk that we're going to do throughout this. So here we have a really simple tax equation. The tax you owe to the government is just the tax rate multiplied by income. And so to get started with our model, we're going to import ParamTools and create a taxes class. This taxes class subclass is the ParamTools parameters class, and it has one class attribute, the defaults. And this is just a dictionary with the parameters that go into our model, in this case, just tax rate. And this tax rate has a title, tax rate. It has a description, the percentage of income that goes to the man, and the data type is a float. The default value is 10%, and it has some validators, just one, the range, and minimum value of 0, maximum value of 1. That makes sense. It's just a simple rate. There are other validators like like choice, so the user has to input a value that's one of a discrete set of choices. Or you can also have different data types. You could have an integer or a string or a date. This class just has one method. It implements this equation that we defined above, where we're grabbing the tax rate and getting to the value and multiplying that by the income that the user passes in. So we create our taxes class, we create our taxes object, and we calculate our taxes for someone who's making $50,000 a year. And so that person is paying $5,000 in taxes. So that's 10% of 50,000, so that makes sense. We have these validation rules. What happens if we break them? Let's pass in a negative value and see what happens. We get a validation error. That's exactly what we were hoping for. So the tax rate is negative 0.1, and that's less than the minimum value of 0. One thing about taxes is that they tend to change over time. So let's make sure we can handle updates to our tax model. So suppose the government wants to raise taxes in 2021 to 15% of income. In order to model this correctly, we need to add some information about what year it is. Because if we don't have this year information, then we would just wipe out the prior tax rate. It'd be harder to compare what taxes we're paying in one year to the taxes we're paying in another year. So we do that by creating the schema object, and it has a labels object in it. And this contains one year label, and the type is an integer, and it has a range validator. The minimum value is 2020, and the maximum value is 2030. And our new default value just says the tax rate takes effect in 2020, and the value is 0.1. And then the run method is updated so that we're getting the right tax rate for the year that the user is passing in. So we create our new taxes class, our new taxes object. We're going to do the same calculation as before, but we're going to specify what year we want to calculate our taxes in. So we're doing $50,000 in 2020. That's the answer we're looking for. We're going to calculate our taxes, or we're going to update the tax rules for 2021 to the tax proposal that we presented up here. So we're going to raise taxes to 15%. And then we're going to take a look at tax rate. And so the new value is 15% in year 2021. And ParamTools knows to do that because you passed in a list with the dictionary, and the label year isn't in the default values. And so this new value is just tacked on to our parameter values. And when we run our tax model for year 2021 with our $50,000 income, we get 7,500. So that works. Looks good to me. And next, we need to make sure that we can calculate taxes for multiple years. This is helpful if we want to look ahead and see how our taxes are going to change in the future. So we could add a run all method like this, but this is kind of cumbersome. On the other hand, we could just do this with NumPy arrays, because all we really want to do is take an array of tax rates and multiply that by some value of income that we're passing in. And ParamTools has really good support for NumPy arrays, and all you have to do to tell ParamTools that we want to work with NumPy arrays is add this operators object, and it has one member array first. You set that to true, and then ParamTools will try to convert your parameter values into NumPy arrays. And we're going to update our default values for the tax rate so that we have a tax rate for all the years in our 10-year window. And then we update our run all method so that we're back to just multiplying the tax rate times the income that's passed in by the user. And we take a look at our new taxes object and our tax rate values, and it's a NumPy array. We can work with it just like all NumPy arrays. We calculate taxes for our window, and it's $5,000 for all 10 years. And that makes sense because our income is $50,000 for all 10 years, and the tax rate is 10%. So we have our government's plan to increase taxes to 15%. So we're going to do that right here. And we expected the effects to be permanent, but they really, according to this, the government's tax plan only goes into effect for 2021. And so we need to update our adjust method so that the tax rate is updated for all years in our budget window. And we do that just by looping over the years from 2020 to 2021 to 2030. And we take a look at the tax rate, and it's updated correctly. So we're in business. Our tax model is working just like we were hoping. All right, so now that we've built a simple tax calculator, let's talk about the tax calculator. This is the real deal, and it takes on all the complexity of the individual income tax code. And tax calculator it's used by presidential campaigns, the legislative and executive branches in the U.S. It's a serious model used by serious people. And when I created ParamTools, one of my goals at some point was to get ParamTools and tax calculator working well together. When ParamTools was created, I wanted it to be general enough to work with a lot of different kinds of models, but it was always helpful for me to look at tax calculator and think, okay, this works for a lot of different kinds of models, but does it still work for something as complicated as tax calculator? And that was just a nice guide for me as I was developing ParamTools. And so over the past couple of years, I've kept up with this project, keeping tax calculator and ParamTools close together and trying to think about how they could be integrated one day. And one thing that you should know is that tax law is really complicated, as I've been saying, and I really had to dig into it and learn how to update different parameters to get this all to work. And even beyond tax law, this is just a general software design challenge. Tax calculator is complicated. It's been around for 5 or 7 years. There are a lot of notebooks laying around that have done policy analyses with tax calculator. So I don't want to come through and try to swap something out with tax calculator and have it break people's notebooks from years ago. Tax calculator also has a really sophisticated and thorough test suite, and so I need to be careful that to be good to that test suite and to take care of it if I'm ever going to try to really fully integrate ParamTools and tax calculator. So kind of as I went along this process and thought about getting tax calculator and ParamTools to work together, I really tried to keep an eye on how I could work with tax calculator's test suite so that I could add new code without modifying tests, at least only the most minimal amount of changes to the existing tests. And I wanted to make sure that I could add new tests too. And then also the parameters class that existed before tax calculator and ParamTools started working together was tough to read. There's a lot of low-level code that you had to parse through in order to understand exactly what was going on with how data was being read in or updated. So I wanted to replace that with some higher level abstractions and just make it a little easier for more people to work on. And so I set about working on this project, and really it unfolded in 4 stages over maybe 1.5 to 2 years. And at the very beginning, I just wanted to know, can I load the tax calculator defaults file? And then I did a toy implementation just to kind of see how close ParamTools was to working with tax calculator and get some feedback from the community. And then I did a third-party package that could be used with tax calculator, and I got a lot of good feedback from that. I learned a lot about how tax calculator's internal logic works. And then I eventually did full integration, open a PR to tax calculator, and saw that all the way through. So very beginning, I was working on tax calculator's default inputs and working with the ParamTools version of them to make sure that ParamTools could handle tax calculator concepts, and that I had defined a standard format that was flexible enough to still work with tax calculator and handle the complexities that it has. And then I also focused early on making sure that the parameter values were accessible as NumPy arrays. And this is just really important in the Python ecosystem so that you're interoperable with all the great tools in it. And then once that was working and ParamTools is getting some adoption, I circled back and did a toy implementation with tax calculator's indexing logic. And that hangs out in this notebook here. And I kind of wrote it up as a blog post. I added different levels of different layers of features to make this all work. And I did it all in a very custom and specific manner. And at the end of the notebook, I was able to do an adjustment with a ParamTools style inputs and a tax calculator style inputs, and I was able to compare that the values were the same. And that was a big deal to me, just to get everything to match up and see that, okay, ParamTools is a serious project and it can handle this pretty tough logic and that tax calculator implements. But what I wound up is with this index parameters class. And when I showed this notebook to tax calculator developers and other people in PSL, I said, hey guys, look what I've made. What do you think? And should I just go ahead and open up a PR to tax calculator? And they're kind of like, whoa, not so fast. This is still pretty complicated. We already have our own complicated code. We don't really need your complicated code. But it would be cool if ParamTools could just do all of this stuff in a general way and just supported this out of the box. And then it would be worth it for a tax calculator to start thinking about using ParamTools. And so I realized I needed two new features. I needed to be able to extend values over multiple years, and I needed to be able to index these values to inflation. And heading back over to our notebook, I'm going to show you how these two features work in ParamTools, and now that they're in the project, and I think you'll see how much power they give to ParamTools and how much you're able to do with them. So in our previous example, we updated the value in 2021 in this array example, and it wasn't carried through for future years, which is kind of frustrating. And we also had to define all these values here for all the years in our window, even though the value of the parameter isn't changing. It's still 0.1. So in this multi-year taxes class, we're going to do this a little bit more concisely, and it's gonna have more functionality. And all we need to add is this label to extend member of the operators object, and we're going to say we want the parameter values to be extended using the year label, and ParamTools can look at the year label and see its type integer, and it has a range from min 2020 to max 2030, and by default, where ParamTools assumes this that the values from 2020 to 2030 are going up by 1, so it's going to take on values from 2020, 2021, 2022, and so on. But you can modify this so it increases by 2 or 3 or some other step besides just 1. A run all method is the same. We're back to just having a list with one value, a dictionary with the year 2020, value 0.1. Create our multi-year taxes. We do our update, check our tax rate. Oh, we need to create our multi-year taxes class, our new one. And now we do that, and we get our perfect, we get the value set in 2021 to 15%. And then for the rest of the years in the window, it's still 15%, but we have this auto attribute, which is important for internal ParamTools logic, but you could also use it if you want to add your own custom extend logic. We calculate our taxes for the 10-year window, and we get 5,000 and 7,500 for the rest. So it's working like we're hoping, and this is pretty powerful. So this is very concise. The values are extended in a simple, intuitive way. We're really getting somewhere. And so the next concept that ParamTools needed to support is, once it could extend values along multiple years, is we needed to have logic for how those values should be extended. And by default, ParamTools handles indexing, so you can grow parameter values according to some rate. And so this models the case where a parameter value is growing according to inflation, and so you can index a value to inflation. And we're going to add a new parameter to demonstrate this. It's a deduction parameter, and all it is we're saying we're going to take our income, we're going to subtract out the deduction, then we're going to multiply that adjusted amount by the tax rate. And that'll be our taxes owed. And so first, let's talk about our deduction parameter. It's just the amount you deduct from your income. It's a float parameter. It's indexed. It has a default value in 2020 of 10,000, and the minimum value you can take on is 0. And we update our operators object to say that we are using an extend function. And that just means that ParamTools is going to call a method called extendFunc, and that's going to return the next value, as ParamTools is extending the values for a parameter. We have our index rates, and ParamTools will use this by default to extend values for multiple years. And we have a new method for adjusting our income for inflation, because that's going to be affected in addition to the deduction parameter. And we create our index taxes class, new taxes object, check out our deduction. It's growing according to the inflation rates. And we run our taxes for 10 years, and we can see that they're going up a little bit every year just due to inflation. So this is a pretty sophisticated model, given that it's only 50 lines of code, and a lot of it is just basically a dictionary specifying how the inputs should be modeled. And now we're going to hop back into our journey for getting tax calculator and ParamTools working together, and see how these features kind of brought ParamTools the rest of the way to being able to work with tax calculator in a serious way. So the next step was tax params, and opening a PR in tax calculator seemed like it was going to be hard. There's a lot of extra stuff there. It'd be hard to test everything. It'd be really hard to figure out if I'm implementing all the indexing and update rules correctly. And so I just did it in isolation, and it also made it easy because I could compare values on the tax params object with values on the tax calculator object to make sure I was doing everything correctly, and I didn't have to worry about all kinds of other tests failing. And I could pass this to a calculator object and calculate the effects of some tax reform using the ParamTools styled update, and the differences carried through. The result, the calculator ran. There were no errors. This was a big deal for me. It made me really excited to see everything run and there to be differences in this table, meaning that the parameters were updated and everything went through the tax calculator model like it was supposed to. And so I shared this with my friends in the tax calculator community and PSL, broadly, and I asked for feedback, and people were impressed. They thought this was a nice project. I'd even documented the algorithm the tax calculator used to update parameters, which was not documented very well in the tax calculator project, and so I gave back a little bit. The tax calculator there, I found a weird indexing bug. It was like way edge case. It probably would never be hit otherwise, but I couldn't figure out why the values weren't matching in tax params to the values in tax calculator. And there was a bug in tax calculator that I found that way. And so there was mutual benefits all around. And the tax calculator team suggested that I open a PR and see if I can just get this merged in the tax calculator. That way it can really fully be reviewed before it's used by anyone else, either in the tax calculator ecosystem or someone who's just stumbling along the project. We don't want someone to do some analysis. And then there be a bug because this wasn't reviewed correctly. And so a few months later, I started working on this work in progress PR for tax calculator to use ParamTools. And took maybe a month or two of just kind of working on this when I had time and energy. I would get, one section of the test to pass and move to another section of the test. I'd circle back, I would document. I was always kind of cleaning things up and trying to get the next portion of the test to pass. But eventually all the tests passed, and I opened a PR, and and I worked with the tax calculator team to get it merged. Over 2 months, there were 67 comments, but eventually it got in, and it's easier to work with now. The parameters classes, a week or two after this PR was merged, someone else opened a PR that modified the parameters class, and this modification fixed a long-standing bug in the tax calculator indexing logic that would have been hard to fix if tax calculator wasn't using ParamTools. And so that someone else was already able to come through and modify the code and improve tax calculator. That was a huge win. That just means that it was a little bit more readable, and people were understanding what was going on a little bit better. So what did I learn from this? I learned that it's important to work in the open and share your results and just get feedback. If I'd worked on this by myself, for 2 years, I might have gotten done, and I could have asked people, hey, what do you think about this project? And they would have been like, oh, we actually like what we have, sorry. And I would have been, that would have been a lot of work that I missed. And then also, you should experiment and prototype. Don't just go for the perfect solution right off the bat. Just try to get something to work and try to learn from that first implementation, and then try to come up with better and better solutions after that. Finally, just spread out your effort, especially for an open source project that you're doing on the side. Make sure you take breaks. Maybe work on other projects too when you have time. Just do it when you have energy. That was really helpful for me. And here, now that we've talked about taxes for 20 minutes, let's think through a couple other potential use cases. Maybe you can model the spread of COVID and use a ParamTools parameters class in the back end. Maybe you have some parameters for social distancing level, or a flag for mandatory masks. Do you allow indoor restaurants, and so on? You could have the ParamTools in a business analytics pipeline. Your parameters for your model could be, number of new users, number of new trials, revenue from subscriptions, and more things like that you could then feed into your analytics model. So what's coming up next for ParamTools? I want to just generally improve the documentation, both for ParamTools and for models that are using ParamTools. I want to try to integrate with other parts of the PyData ecosystem, like Bouquet. It'd be great if you could take a ParamTools parameter and then there'd be like a function or a method where that would return a Bouquet widget that you could just embed in a chart. I think better integration with tools like Pandas, where you could go from a parameters class to a Pandas data frame and then back, doing those conversions. I think a TypeScript implementation would be really nice for ParamTools. That I've done something like this for Compute Studio, but I would like to build a standalone version so that other people can more easily work on it and develop client-side applications. But that's what's on my mind and kind of where ParamTools is going. But can't wait to hear feedback from people who've watched this talk, and thank you for listening, and I'm looking forward to speaking with you on the panel.